So good morning, everybody. Thanks very much to the organizers for having me here. And if you'll permit me just a moment to have a couple of reflections based on what I've heard over the last day. So I was particularly intrigued by what Lynn had to say yesterday about the 1992 Fifth Circuit Court ruling and how that has really cemented a lot of activities in place. This preference for end-of-pipe solutions, and you've actually heard a lot about that today. The closer you get to the customer, the more you can talk about toxics. The further back in the supply chain you go, the less you can talk about that. Because the way chemists do what they do is a lot like what you saw in that Paracelsus quote. That is, they use what is at hand. And the basic building blocks and what is at hand for your average chemist is inherently hazardous and toxic. And that is fundamental. The chemical or chemistries that chemists use are largely driven by historical precedent, and they also are based in technologies that are 150 plus years old by and large, and they are inherently using toxic materials. And chemists are creatures of habit, and they use the same things over and over again. So I'm going to be talking a lot about that particular idea and how green chemistry really has got to talk a lot about changing behaviors and preferences in the people who, if I took a poll, I doubt there are too many chemists, bench-level chemists, who are actually designing molecules in symposia like this. And that's a problem. And one toxicology course, or even two, given to a chemist is not going to solve that problem. The entire system is likely to have to change. So I'd like to talk to you a lot today about challenges but also successes and how we think about greening the supply chain and particularly about helping businesses. So why do we need green chemistry in the supply chain? And I want to go back to what chemists do. Chemists do what they do because the molecules that they're working with are reactive molecules by definition, right? If they didn't use reactive molecules, you wouldn't get them to be thermodynamically favored. In other words, you won't get over the activation energy barrier, or kinetically favored, which means that the rate of the reaction wouldn't proceed. So they have got to use the molecules that they do, so they think. They don't think about entropic reactions or reactions that take place by ordering molecules, but they think about the enthalpic way of doing that. And I know that's a lot of deep chemistry that I suspect most don't know where I'm coming from, but the point is the entire way in which chemists are educated is educated in a way which doesn't necessarily get them in the place that we need them to be. They also talk about yield, which is not a good measure for green chemistry, which is heresy to most chemists, but it's true. They use chemistries and chemicals that react in predictable ways. We need predictability in our lives. They're easily obtained, right? The interesting thing, again, about the Paracelsus quote is it's the things that were readily at hand. They ground up bones or they used herbs or whatever it happens to be. Chemists do the same thing. They reach for the same solvents that they've used for years. They use the same framework molecules. They go to Sigma Aldrich or to the same purveyors of chemicals, and that's all they use, right? And so toxicity and hazard is built into the way in which chemists do what they do. You can't escape it unless you change the way chemists do what they do. And the last thing is really about engineering side and the sophistication of technology. And as you heard the last speaker in particular talk about what's required to change over, and that in-ground capital is historically a big problem. We've talked a lot, and I'm not going to dwell on these things, but clearly we have a lot of sustainability risks in feedstocks, efficiencies, missing data, so on. Previous speakers have all talked about these things. These are enormous barriers to green chemistry or to trying to get people to think about green chemistry. Innovation is something that a lot of people in green chemistry speak about. We heard a little bit yesterday about whether or not the legislation actually spurs or inhibits innovation. I would say that it actually does spur innovation. There's been studies to show that. If you regulate something out of existence, people don't have any choice but to find something different, right? It's not really the preferred way to do it, but it will get people to think about it. So where green chemistry really is trying to meet is that environmentally preferred, economically viable, equal or better performance. And ultimately, that's the sweet spot. We were asked to really dwell on what is it that businesses find in green chemistry or in toxics reduction. And you can go back to traditional business measures like revenues and earnings. If you're not having to deal with managing toxic chemicals, it's inherently cheaper. If you can run a laboratory without hoods, which I guarantee you that the biggest cost of running a laboratory is ventilation, once passed through heating and cooling in a hood, not the chemistry, right? But if you could do chemistry in a way that you didn't require hoods, then you could have a substantial decrease in energy in R&D. So cost reduction, risk reduction, there's a huge number of intangibles that you've heard in the J&J talk and Dow in terms of customer and outward-facing view of customers for products that are perceived to have a risk. And even in spite of the fact, as was pointed out, formaldehyde in an apple is far greater than what you might find in J&J's product, but people are still very concerned about those toxics in the supply chain. One of the ways in which we at the Green Chemistry Institute have been trying to enable green chemistry is really from all parts of the supply chain. And we've developed this concept of roundtables. And we've asked companies to get together and to talk about issues in a collaborative and non-competitive way. The way this works, for example, in pharma is the greatest, and it's the first example of a roundtable that I'll talk a little bit more about. But think about it. What pharma competes on is the active pharmaceutical ingredient, not the way in which we make it, not the chemistries, not the chemicals. So there's an awful lot of room to talk about how we can get toxics out of products and processes without affecting what we actually compete on, which is the active pharmaceutical ingredient. So addressing technical challenges, decision-making tools, informing the research agenda, use of good science in policy setting and influence throughout the entire supply chain. This is a very busy slide just showing you that we have 3 roundtables. The pharmaceutical is the oldest. It was started in 2005. Chemical manufacturers and formulators have been started in the last 3 years. So the chemical manufacturers is the furthest back. And to be honest, it's the hardest roundtable to get to the table. And the reason for that is largely because they compete at lower margins, number one, and they compete with, in some of the same product areas. So it's more difficult, and also they're more diversified than you will find in some of the consumer products or formulators. So it creates more of a barrier. However, having said that, there are areas like alternatives to distillation. So I'd like you to think about green chemistry writ large and the way in which chemicals move through the economy. And distillation represents over 25% of the energy use, and there's a whole lot of issues with toxics in the environment from energy use. So if we can come up with alternatives to distillation, it actually will drive a lot of very good behaviors and outcomes from a green chemistry standpoint. The pharmaceutical roundtable and the formulators, again, are far more customer focusing, so the discussions are a lot easier to have. In pharma, the idea of rational molecular design is inherent to what they do. The interesting thing is to make a molecule biologically active and pharmaceutically active does create problems from a standpoint of toxics and bioaccumulation and persistence. However, we can do a lot to try and address that, and we can take tools that have been developed in pharma and try and put them into either the chemical manufacturing community or many parts of the chemical manufacturing community. An example of a more sustainability issue is this graphic at the bottom of the slide here, which shows where things come from. And the catalysis is responsible for probably 40 to 50% of the chemical supply chain. So in other words, it's used everywhere, and everything that you use on a daily basis can usually be traced back to some catalytic process. The darling metals in catalysis are platinum group metals. And there's a sustainability issue with that, which isn't the subject of this particular one, but we can go to more effective catalysis using base metals, that is earth-abundant metals, and enzymatic approaches, and get us out of these things. But the point of this is what people don't realize is that in mining, for materials that we use regularly in the chemical supply chain, we release a large number of toxics into the environment. And that's something, again, that is not really perceived at the bench level of a chemist who's choosing a catalyst. There's lots of things from an engineering perspective that we can do. Pharma is very batch chemical operated, and moving to bioprocessing and continuous processing is a way to increase mass and energy efficiency, and again, to reduce the production of toxics and unwanted byproducts and so on and so forth. So there is a huge amount of technology possibilities. Separations and reactions account for an enormous amount of energy use and waste. And just simply focusing on better solvent and solvent use has an enormous possibility, again, for taking toxics and waste out of exposure. The Formulators Roundtable is a very interesting group. They're largely composed of cleaning products. So the thing you heard about nonylphenol ethoxylates is something that they would be very alive to. Also cheilants, and I believe J&J talked about fragrances and things like that, the non-musk and that kind of thing. These are used in cleaning products as well. So there's a lot of room to talk about classes of compounds that we'd like to get out of the supply chain. So cheilants, surfactants, fragrances, these are all things that we can have discussions about and work to try and generate alternatives that are safer. A lot of this and a lot of the roundtable's work is actually to identify these kinds of things and to work through academia and other means to try and come up with alternatives. So I wanted to talk a little bit about institutional inertia, and this is a huge problem. I've talked about it a little bit from an educational standpoint, but also just in the way that we do what we do in chemistry, there's a tremendous amount of inertia that has to be overcome. In-ground capital, again, sets in place a lot of hurdles. The way in which we do financial analyses, so what is actually more sustainable or more cost-effective, is generally not considered from a life cycle perspective, and it should be. And the last bullets are really about human behavior, and I would say that a lot of what we talk about boils down to behavioral changes in people at the bench level. So if I had more time, I'd talk more about green chemistry is beyond just hazard and pollution reduction. As important as those are, there's many other things that have to do with sustainability that green chemistry is about. Early design, again, I could talk for hours about this. You have to think about this from day one. This preference for end-of-pipe solutions is absolutely fatal to sustainability and green chemistry. Readily available tools are there, but it's a key point that chemists aren't aware of them and they don't know how to use them to change the kinds of things that they do. So that's a problem. And lastly, the roundtables are about promoting and implementing green chemistry and engineering. So thanks very much for your very kind attention.
Great. Okay. Next up is Beverly Thorpe. She's the Consulting Co-Director of Communications and Advocacy for Clean Product production action. She has researched and promoted clean production strategies internationally since 1986. And her current focus is the promotion of green chemistry within government, public policy, and company practices. And she continues to train, teach, and publish materials that advance clean production strategies internationally.